Hi, I'm David Wahlberg from Pixelmania, and I'm going to do a short demo of our Nuke plugin NNSuperResolution. NNSuperResolution is an upscale plugin based on a couple of the best performing artificial intelligence algorithms available today. This means that you can increase the resolution of your input material times 4. We start by showing you an example of upscaling a 1K crop out region from a native 4K Alexa plate. That crop region is then upscaled to become a new 4K material. You see the result on the right and a standard bicubic scale up on the left as reference. You can also upscale rendered CG with alpha channel support. Here is a low-res render upscaled using a standard bicubic filter, then compared with the NNSuperResolution result on the right. To easily be able to compare, we do an extra zoom in to show the actual pixels. Alright, so let's dive into Nuke and do a live demo so you can see the plugin in action. First, I'm just going to show you the computer specs on this workstation, just so you know what it's running on. It's a 32 gig of RAM, AMD Ryzen 5, and more importantly a GeForce RTX 2080 Ti. So not the latest and greatest, but a pretty good one. I'm also going to clear the cache in Nuke, so you know that nothing is pre-computed, as said. I'm going to start with showing the NNSuperResolution on still photos. Took a couple of snaps on a trip to the US a few years ago, so I'm going to start by doing a NNSuperResolution node here and connect it. This is the source image, and I'm going to calculate the result. So right now it's calculating the still image upscaling, and this neural network is pretty heavy, so it's taking a bit of time, but not too long. Still calculating there. And there you go. It's from 1200 times 800 till 4800 times about 3200. So I'm going to zoom in and do that full screen so you can compare. So this is the source image and this is the upscale. Source image, upscale. I'll show you another region. This is the source and upscale. Let's show another photo. So I'm going to create a new node, source, and calculate the upscale. This neural network is having about 15 million parameters that are tuned. That's why it's a bit heavy. But also the reason why it can produce so much detail. Alright, zoom into this one. This is the source and the result. So have a look at the eye region here. You can really see lots of detail. This is the source and the upscale. It's also interesting to pay attention to the defocused areas, how it's doing over here, and the whiskers, of course. Next example is texture, if you're into doing CG and want to upscale textures. So for this one I just went to ambientcg.com and searched for grass, and I downloaded this 4K PNG texture. But to not have you wait for too long, I'm just going to do a center crop. So not scaling it, but just doing a crop out of a 1280 x 720 region of this, just to have it a bit faster. I'm doing the NNSuperResolution plug, connecting it, and looking at the result. So it's upscaling that to around 5K times 3K. The only parameter you probably want to tweak is the max size here, and that totally relates to the amount of GPU memory you have. The more memory you have, the higher you can have max size on, and the faster it's going to compute. If you run out of memory, lower the max size. That's pretty much the rule of thumb. So let's look at this. This is the source and the upscale. Again, source and the upscale. I mean, if you remove this reformat, it will upscale the 4K by 4K to 16K by 16K. That's no problem at all. It's just going to take a couple of minutes. Last example. This is a moving sequence, this cow. So I'm gonna put in a node here, NNSuperResolution, but I'm gonna change it to sequence mode. And that means it's gonna calculate a temporarily stable version instead. So it switches the neural network to another method and another trained network. It's important that you fill in the frame ranges here correctly and also have a decent pre-roll. 5 is usually enough, which means it's going to use 5 consecutive frames to calculate first, and then it calculates the final result. And when you've done that, that takes a bit more time for the first round because it's doing 5 of the images. But when you have that result, you can do the next frame way faster. So I'm going to show that by zooming in here and pressing play. So but first I'm going to show you this frame. So source and result. Again, source and result. I'll zoom out a little bit so you see it more. Source and result. And now I'm going to press L for play. So you can see it calculating frames after each other here. And I get around 5 seconds of calculation time per frame here, which is not that bad. And again, this is from 1280 times 720 to 5120 times 2880. That's it. Thanks for watching.